Hello everyone, welcome back with a new video. Today's topic is about the formation of image by lens. Means how the lenses forms image when an object is kept in front of it. Okay. So to understand the ray diagrams, you have to learn about the three rules. What are the three rules? First rule is in case of concave or convex I am showing. First is suppose this is a convex lens and this is the principal axis. So when the rays passes through the optical center, see when the object is placed, so the rays will come from the object. So first rule is when the rays passes through the optical center, then it undeviates its path. Means whatever be the direction of incident ray, it will emerge from the lens with the same direction. Okay, or along the same direction. This is the first rules. In case of concave also, if we draw the concave lens over here, then this is principal axis, this is optical center. In this case also, same phenomena will happen. The direction of incident ray will be equal or will be same to the direction of the emergent ray or the refracted ray, and when it passes through the optical center. This is the first rules. What is the second rules? Second rules is, look here, this is the convex lens. So by convex lens I am showing because in all cases both will be same. And here suppose the ray, we know that in case of convex lens it has two focal length. So f1 and f2 I am giving. So here it is 2f1 means center of curvature. So here it is 2f2. So when the rays are parallel with the principal axis, then after refraction it passes through the focus. It passes through the focus. Okay. So when the rays are parallel with the principal axis. Now look, in case of concave lens, what will happen? This is rule number 2. So in case of concave lens, look, this is principal axis, and when the rays are parallel, with the principal axis, then we know the convex lens is a converging lens, but the concave lens is the diverging lens. So after refraction, the rays diverges from the point of incidence. Now see, these rays cannot meet. Suppose if we take one more rays, then it diverges from the point of incidence. The incident rays are parallel to the principal axis. Now what will happen? See, in case of concave lens also we have seen it has also two focal length. Okay. So that rays cannot meet, they never meets in this side. So if we extend it backward, they meets at the focus. Means in convex lens, after passing through the lens, it passes through the focus. When the rays are parallel, incident rays are parallel with the principal axis. But here, when the rays are parallel with the principal axis, when it falls on the surface of the concave lens, then it appears to come from the focus. It seems it is appearing or it is coming from the focus. Okay, it seems it appears to come from the focus. This is for the concave lens. Okay. Now in third cases, for convex lens, this is the principal axis, and when the rays, see this is f1, this is f2, and this middle point is the O or optical center. Now the third case is when the rays passes through the focus. When the rays passes through focus, then after refraction what will happen? This is the incident ray which is passing through focus. So after refraction, it becomes parallel with the principal axis. Just this is the opposite. When the rays are parallel with the principal axis, then it passes through focus, or when the incident rays are passing through the focus, then it becomes parallel with the principal axis. These are the three rules. With that three rules, we can able to draw the ray diagram. Means when the object is placed in front of the, in different position, when the object is placed in different position in front of the convex lens, then where the image will form and what will be the nature. Okay. What is real image? The definition we know. The definition is the image which can be obtained on the screen, that is called the real image. Now, and in another way, we can say, suppose this is the lens, and one object is placed over here, and I will apply two rules out of these three. One ray is passing, or one ray is parallel with the principal axis, and after diffraction it goes through the focus. Okay, it passes through the focus. And another ray which is passing through the optical center, it undeviates its path. So now we can see after diffraction these two rays are meeting at this point. Means these two rays they actually meets. So when the two rays are meeting at a point, so there the image will form. So this is the image. Suppose if we give A and B, as the rays are coming from B, so this point will be B, and the rays which are coming from A, so this point will be A dash. So A dash and B dash I am giving because object is A, AB, and image will be A dash, B dash. Okay. Now look, the image is, we can say the image is inverted. So we can say the real image which is inverted. So what is the definition? The image which forms by the refracted ray which actually meets. So the image forms by the rays which actually meets, then the image is called the real image, or the image which can be obtained on the screen, that is also called the real image. Clear? Now what is virtual image? Look, virtual image means when the refracted rays actually they do not meet. Why? See, suppose in case of concave lens, now this is principal axis and suppose the object is placed over here. So again what I told, you have to take 2 out of these 3. So here I have taken here 1, and after refraction it diverges the rays, and one more rays I am taking which is passing through the optical center. Now look, these two rays, they do not meet. They cannot meet, they never meet with each other because they are diverging. Okay. Now what will happen? Where the image will form? In case of convex lens, if we place one screen over here, I am telling for the convex lens, if we place one screen over here, then the image will form on the screen. But in this case, if we place one screen over here, then the image just does not form, because it will form a virtual image. Means the images which does not form on the screen, that is called the virtual. And what is the concept of virtual? See, these refracted rays, they do not meet actually, but if we extend it backward, this point obviously it will be focused, and they are meeting at this point. They are meeting at this point. So here the image will form. Means they actually never meet. They do not meet actually, but they are appearing. It appears to come from this point. Means the image will form over here. This type of image is called the virtual image. Now the rays actually do not meet at this side, but they appears to diverge from the point. Okay, so these images are called the virtual image. But if we place our eye over here, then we can able to see the images formed by the concave lens, because eye itself is a convex lens. Okay, so the conclusion is, what is real image? The image which can be obtained on the screen, that is called the real image, and which cannot be obtained on the screen, that is called the virtual image. Okay. Now I will show the ray diagram for the different position of the object. So first one is, I am taking the U is at infinity. Means the U, what is U? U is the object distance. Means object is placed at infinity. So for the convex lens, which is the principal axis, and we can consider when the object is placed at infinity, so the rays, means incoming rays, will be parallel to the principal axis. Okay, parallel to the principal axis. So as the rays are parallel with the principal axis, then we get from the first law, so when the rays are parallel, so after refraction it passes through the focus. So it passes through the focus. Okay, this is the refracted rays. Now we can say here the refracted rays, they actually meets. Okay, so the nature of the image will be, okay, nature number one, they are actually meeting, means we can say the image will be real. Number two, remember real image always inverted. If we place a screen, but this here the image will be point sized, but in another cases I will show, here the real image means when the actual refracted rays are meeting, it will form an inverted image. Wait, so that now remember here the real image will be always inverted. Okay, number three, what is the nature of the image? Two nature we got, and number three will be the object is placed at infinity, means the object is placed at far away from the lens. So obviously this is point sized image, the image will be point sized. So here we can write the nature, it is diminished. Okay, these are the three, or one more you can write, it forms at the focus also. Okay, in second case the object is placed at infinity, but the rays are coming from the object which are parallel, but they are not parallel with the principal axis. Then where the image will form. Look here, suppose this is a convex lens, this is principal axis. What I told, the rays are parallel, but they are not parallel with the principal axis. So this is optical center, f1, f2, f2 here I am giving. Now look, the objects, from the object the rays are coming. So one rays I am taking which is passing through the optical center, so it undeviates its path. Okay, now another rays I am taking which is passing through the which is passing through the focus. So after refraction, we read from the third rules, after refraction it becomes parallel with the principal axis. So we can say this is the midpoint here, means these rays are coming from the top. Suppose one large object is placed at infinity, so here I am giving this B, this object is placed at infinity and it is A, so these rays are coming from the top. Okay, so by applying the rules, I applied here two rules, so by applying the rules we got the meeting point over here. And one more rays, not only one, so many rays will come from A also. So this point A means obviously here A dash, and this is coming from B, and this point will be B dash. So the image will form like this. Okay, now look, here it is inverted. If we place the screen over here, then the image will form which is inverted. Means here the refracted ray, they actually meets, means here the image will be real and which is inverted. I told real image always inverted. Okay, so the nature of the image will be, first nature, number one, this is real. Okay, number two will be real, means it is inverted. Number three will be highly diminished. Okay, highly diminished. Clear? Now one thing you have to keep that in your mind. In that case, the image always form at the focal plane. What is focal plane? Think about one plane which is perpendicular to the focus. Means suppose this is the plane, and which is perpendicular to the focus. This is called the focal plane. Okay, and the image will form at the focal plane when the rays are parallel, but they are not parallel with the principal axis. Okay, and in this manner the convex lens is used as the burning glass, camera, like that. Okay, and to use the lens as a burning glass, when how it works, when the sun rays are brought to focus on the piece of paper which is kept at the second focal plane or second focus also. Here you have to place the piece of paper over here, then this is the convex lens, then we can burn the piece of paper by using that lens. Okay, in this manner it is used. Now consider the object is placed beyond twice f, means beyond the center of curvature of the lens. So where the image will form and what will be the nature of the image. So here I am taking the convex lens. This is f1, this is f2 and twice f1. So this will be twice f2. So here I am writing twice f2. look what I told, the object is placed at beyond A, so name I am giving A and B. So you have to choose two rules out of these three. So one ray is, consider one ray is coming from the top and which is parallel with the principal axis. So after diffraction it passes through the focus. So it passes through focus. Okay. Now another rays which are passing through the focus, you can take the rays which is passing through optical center also, but I am taking here the rays are passing through the focus. So after refraction it becomes parallel with the principal axis. So it becomes parallel with the principal axis. Okay. Now look where the image is forming. This refracted ray, they actually means here the image will form as the rays are coming from B. So this point will be B dash. Why B dash I am giving? This is image, this is object. So the image will form like this. See, another rays also it will come from A, means it will lie on the principal axis also. That's why this point will be A, or in the A dash I am giving. Now look, the image will be real obviously. So what will be the nature? Nature will be real. Number 2, inverted. And third rule should be, it will be little bit smaller than the size of the object. So normal diminished I am writing. Okay. These are the three nature, or you can write it will form in between F2 and twice F2 also. Okay. Number 3, when U equals to twice F, means when the object is placed at the center of curvature, means at twice F1. Look, here this is F1, so twice F1 I am giving, this is F2, and here twice F2 I am giving. So object is placed at twice F1, the name I am giving AB. So choose again same rules. First is parallel with the principal axis, so it will, after refraction it will pass through the focus. Now another rays I am choosing which is passing through the optical center. Or sorry, from the optical center I am taking, or you can take the rays which is passing through the focus also. So I am taking the rays which is passing through the optical center. Okay. Now after refraction it undeviates its path. So here is the meeting point. Now look, the rays actually meets. So here the image will form. See, rays are coming from B, and this point will be B dash point because it is an image. So 2F2 I am writing over here. Okay. Now look here, this is 2F2. So the object position was 2F1, and here the image position is also twice F2. So what will be the nature? The refracted rays actually meets, means the image will be real, inverted, and same size. These images will be at same size. Okay. Now in fourth case, when the object is placed in between F and twice F, means F less than U less than twice F, more than F but less than twice F. What is the meaning? Suppose this is convex lens, principal axis F1, F2, twice F2, and it is twice F1. So extend it, and the object is placed in between F and twice F, F1 and twice F1. So apply the same rules. First one is parallel with the principal axis, so after refraction it passes through the focus. Okay, so it passes through focus. Now another rays I am taking which is passing through the optical center. Okay, you can take the rays, one ray which is passing through the focus also, F1 also. That also same diagram will come. Now look, it undeviates its path, so the image meets at this point. So they are actually meeting, mean the image will be real. So this point will be B dash, I told so many times. So this is B, so and this will be A. Which one will be A? So this point will be A dash. Now look, what will be the nature? This is twice F2. So the image is forming beyond twice F2. Okay, so what will be the nature? What will be the nature? Number 1 will be real. number 2 inverted. Okay, number 3, obviously see the size of the image will be larger than the object, so it is magnified. Or you can say the image is formed beyond twice f also. Okay, now in fifth cases, the u equals to f means what is the meaning? When the object is placed at the focus. See, whatever I have explained over here, so in all cases when the object is placed over here, means beyond the lens, then there the image will form, and the image will be obviously inverted. Why? Because they are real. Okay, and the real image always forms on the screen. Now I'll explain when the object is placed at focus. Suppose this is object A and B. This is f1, f twice f1, and O, f2, twice f2. Okay, so take two rays. One is parallel with the principal axis. So after refraction, it passes through focus. Okay. Now another rays which is passing through optical center. Okay, so it undeviates its path. Now look here, the refracted rays are meeting or not? See, these rays are parallel with each other. Means the refracted rays are parallel with each other, and we know the parallel rays meets at infinity. Okay, so what will be the nature of the image? So first nature will be they are meeting at infinity. So obviously they will be real and inverted. But what about the size? See, object size is this much, A and B. But when that refracted rays meets at infinity, so the image size will be very, very larger than the object. So this is highly magnified. Okay, this is highly magnified. These are the three natures. In this manner, the convex lens are used in spectrometer to get the parallel rays. Okay. Case number 6, when u less than f, means when the object is placed in between O and f. Look here, suppose this is the convex lens and principal axis. So this is f2 and f1, twice f1, no need to write. Here suppose the object is A and B, optical center O. Now same cases when the rays are parallel, this ray is parallel with the principal axis, so after refraction it passes through focus. It passes through focus. Okay. Now look here, one more ray I am taking which is passing through the optical center. So it undeviates its path. Now look here, the rays are diverging, means they never meet. So where the image will form? Now look, if we extend it backward, now the rays are meeting at this point. Means here the image will form. This is A dashed, this is B dashed. Now look, this type of lenses, in this manner we can, the lens is used as a magnifying glass. Magnifying glass means by using the magnifying glass we can able to see a larger image of a smaller object. Means when we are reading a newspaper, if we take one magnifying glass, then easily we can see the larger image of the smaller object. Means the use of this ray diagram is the magnifying glass. So here what will be the nature? Nature will be number 1. Look here, the rays, refracted rays, they are actually not meeting. So we can say these are not real, means the image will be virtual. Because when they are not meeting actually, so we have to extend it backward. Then here it is meeting, means if we place our eye over here, okay, then we can able to see the image, larger image of the smaller object. Okay, so that's why this image will be virtual, and virtual image always erect. And number 3, it is magnified. Okay, clear? The total ray diagram I am explaining. See, in first cases we have seen when the rays are are coming from infinity, means when the object is placed at infinity, so the image forms at focus, and when the object shifts from infinity towards twice f1, the image also shifts from f2 to twice f2, and the size of the image gradually increases in between f2 and twice f2. Now, means in that case we have seen when the object placed at when the object placed at beyond twice f1, then the image forms in between f2 and twice f2, and the size of the image diminished than the object. But when the object was at infinity, so the image size will be point sized. But when it shifts towards f1, twice f1, then the size of the image also gradually increases. Now when it comes at twice f1, then the image also forms at twice f2, and the size of the image becomes same. But the image will be real and inverted. After that, the real inverted, and here when it forms over here, then it becomes same. Size of the image is same as the size of the object. Now again, further moving from twice f1 to f1, that time what happens? Means when the object placed at in between f1 and twice f1, then the image forms beyond twice f2, and the size of the image will be magnified than the object. Beyond that, the size of the image is diminished than the object, but here size of the image is magnified than the object when the object is placed in between f1 and twice f1. Are you getting my point? So again I am telling, when the object is shifting from infinity towards twice f1, so image is also shifting from f2 to twice f2, and the size of the image is increasing. But in between, whatever the image will form, the size of the image is diminished than the object. But here see, when the object was formed at f2, the size of the image was point sized. But when the image is shifting from f2 to twice f2, the size of the image gradually increases. And after that, after twice f2, size of the image becomes magnified than the object. Now what will happen? When it placed over here, when it's placed at f1, then the image shifts to infinity. Means that time the size of the image is maximum. When the image is formed at infinity, means size is highly magnified, we can say. Now further moving the object towards the lens, means in this case. Now what happens? Now up to these cases, up to focus, means when the object is placed at focus, the images will be real or inverted. But further moving from f1 towards the lens, then the images will be virtual and erect, and it forms in front of the lens. Okay, this is all about the ray diagrams of the convex lens. Now in concave lens also I will show. First one, suppose the object is placed at infinity and the rays are parallel with the principal axis. So see, in this case the rays will diverge from the incident point because it is a diverging lens. So it has also focal length f1, f2. So here they never meets, but if we extend it backward, it meets at a point, means it appears to come from the point which is called the focus. Means here these images are called the virtual image because it does not form on the screen. But if we see from this side in between the rays, then we can able to see these rays are coming from this object is coming, means the image will form at point f1 or at the focus point. And what will be the nature? And we can able to see the image because our eye itself is a convex lens. Now what will be the nature? Now nature will be number one, virtual. So remember that when you have to extend the rays, the image will be virtual. Okay. So number two, virtual image always erect. I'll show by the another diagram also. Number three, the size will be diminished. Okay. In second case, when the rays are parallel but they are not parallel with the principal axis, then where the image will form, look, I have taken here one rays which is towards the focus. So after refraction it becomes parallel. So in convex lens what we have seen, when the rays passes through the focus, so after refraction it becomes parallel. So in concave lens, when the ray is appearing from the focus, then after refraction it will become parallel with the principal axis. So, and the second case, in second rays, the rays are passing through the optical center. So after refraction it undeviates its path. So see, these rays are diverging rays, they never meets. So after refraction or after extending the rays, these rays, they are meeting at this point. So here the image will form. But as they are actually not meeting, so we can say they cannot form the real image. So the image will be virtual. And what will be the nature? First nature will be virtual. Number 2 will be erect. Number 3 will be highly diminished. Okay, because the object, the rays are coming from infinity, means obviously, see, if we take a rays, these rays are coming from a point which is A, suppose A, and this is B, this is A, this is B. So this ray, this point will be B and this point will be A dash. So whatever be the direction of the object, the same direction we are getting in case of image. So image will be erect. So A dash, B dash I am giving. And it is, see, obviously when the object is placed at infinity, the size will be large, but here the image is diminished or highly diminished, means actually diminished, highly diminished you will write. Okay, in this case I will show when the object is placed at a finite distance, means suppose the object, this is f2, f1, twice f2, this is twice f1. So object is placed at a finite distance, means where what we can measure. So where the image will form. So take two rays. First one which is parallel with the principal axis. So after diffraction it diverges. Okay. Now another rays which is passing through the optical center. So after diffraction it undeviates its path. Okay. See, these rays are not meeting. So if we extend it, see what we read. In case of parallel rays for the convex lens, after refraction it passes through focus, but in case of concave lens, it appears to come from the focus. So this ray will meet at the focus also. Okay. Now see, this is the meeting point. So here the image will form. As this is A and B, this point will be A dash, this point will be B dash. Because these rays are coming from here, means this is the meeting point, means this point will be B dash also. So A dash, B dash we are getting. So nature, nature equals to virtual, number 2 erect, number 3 diminished. Okay. So this is how the ray diagrams you have to draw. In this manner, the concave lens is used in spectacles to rectify the myopia. And what is myopia? And I will make a separate video on it, what is myopia and hypermetropia. Look, just briefly I am telling. Myopia means the problem in the eye, in our eye, when a person cannot see the distant object but they can see the nearby object. That type of problems is called the myopia, and by using the concave lens we can rectify it. And what is hypermetropia? The problem with which a person cannot see the nearby object but they can see the distant object. Then that problem is called a hypermetropia, and by using a convex lens we can rectify the hypermetropia. But here concave lens I am explaining, means this is used to rectify the myopia or short-sightedness also it is called. Okay. Now the conclusion we can draw: when the object is placed at infinity, the image formed at the focus and the size will be diminished, means smaller, and when the object shifts towards the lens, then the image also shifts towards the optical center and the size gradually increases. Okay. And when the object is placed at f2, means second focal length or f2, then the image formed actually at the middle of f2 and O. Okay. And but remember, the size of the image always smaller than the object. Okay. This is all about the convex lens and the concave lens. This for the ray diagram. Thank you.